Welcome to Study Loop.
In this problem, we are asked to see if the sodium isotope, sodium-24, undergoes a beta positive decay or a beta negative decay. In the case of a beta positive decay, the sodium isotope would decay into a positron and a neutrino, and whatever daughter nucleus that would result. That daughter nucleus would have an atomic number Z 1 less than sodium. In the opposite case, in a beta negative decay, the resultant decay products would be an electron and an antineutrino, in which case the daughter nucleus from the sodium 24 parent would have a Z of 1 greater. So in order to figure out which decay process, we need to look at the atomic mass number of the isotope in question. For sodium 24, it has an atomic mass number of 24. But if you look at the stable isotope of sodium, it has an atomic mass number of 22. So the isotope in question has an atomic number greater, that is a sodium isotope 24, the atomic mass number of the sodium 24 is greater than the atomic mass number of the stable isotope of sodium, which is sodium 22. Because the number of neutrons in the sodium 24 is greater than the number of neutrons in the stable isotopes sodium 22, we can conclude that if it goes under a beta decay process, the beta decay process will be a beta negative decay. Now, let's write this out as quickly as we can here. Undergoes this would be beta negative decay. We can write that better. The next part of the problem asks for us to write down the specific reaction that takes place in this beta negative decay. We can do that here. We start out with a sodium 24 isotope. And recall from my earlier explanation, in the case of a beta negative decay, we'll end up with 1 proton greater in the nucleus because the neutron will have decayed into a proton and will spit out an electron. So the element that has an atomic number of 12, Z equals 12, is magnesium. It has the same atomic mass number of 24 here because the total number of protons and neutrons is conserved in a beta decay. And we have a resultant electron, and we have an emergent antineutrino. So to find the maximum kinetic energy of this beta negative decay, we will need to subtract from the parent, from the mass of the parent isotope, the mass of the daughter isotope. In this case, magnesium 24. And then we will convert that change in mass to an energy using our 931.5 conversion constant. That's mega electron volts per atomic mass unit. So symbolically, we have our 24 sodium 24 isotope, and we're going to subtract from that the atomic mass of our magnesium 24. Looking these up in Appendix B, we find that the atomic mass of sodium 24 is slightly higher than the atomic mass for magnesium 24 by about 0.015. Plugging these into this above equation, this value into the sodium isotope mass, this value into the magnesium isotope mass, we find there is a maximum possible kinetic energy of this 24 sodium 24 isotope. And this is a beta negative decay. The maximum kinetic energy in this case is going to be 5.515 mega electron volts. So let's box our answers here. It was actually problem asked for 3 separate things. Make sure we're accounting for all of them. The other thing was the reaction that took place. And the final thing was what, or the earliest thing rather, was what type of beta decay, what the polarity would be in this case. And there you have it.